Mr. P's Science and Math Podcasts. For more science and math concepts, search me out on iTunes by typing Papapodcasts. You can contact me at mrplieberman@gmail.com. Thank you for watching. To 2, 6, 10. When we're going from 1, 3, 5, okay, to 2, 6, 10, look at what the equation was. We went from y is equal to x squared to y is equal to 2x squared. Okay? For us to have gone to that, we multiplied, I'll use a different color here. We multiplied this by 2. Now, let's look at this 1, 3, 5 again, and let's look at the difference here that we got. If we go from 1, 3, 5 to get that difference, we get 3, 9, 15. What did we do to this to get to that? But look at the equation. Y is equal to 3x squared. What we did was we multiplied this, the 1, 3, 5, by 3 to get the difference of the next one. And that's what's going to help us graph all parabolas. Because all parabolas follow what I like to call, what Mr. P personally likes to call, the 1, 3, 5 pattern. Okay? And the 1, 3, 5 pattern is a derivative of the equation y is equal to x squared. And remember, this 1, 3, 5 pattern is based from whatever the vertex is. We have a 1, 3, 5 pattern, but the 1, 3, 5 pattern here, we multiplied by 2. The 1, 3, 5 pattern here, we multiplied by 3. So whatever the A value is going to tell us what the pattern will be for graphing parabolas. So let's look at what the shortcut is. Shortcut to graphing parabolas. When graphing parabolas, we can use our knowledge about the differences in the x and y axes. And if we go back here, okay, we had what I like to call the 1, 3, 5 pattern. But notice here what the difference is always in x. The difference in x is always 1. The difference in y is 1, 3, 5. So in terms of this pattern, x is always going to be looking at 1. In terms of when we look at y, y is what follows the pattern of 1, 3, 5. Okay. So remember that all parabolas are to some extent congruent to the quadratic function y is equal to x squared. The difference in the y-axis is the 1, 3, and sorry, this should be 1, 3, 5 pattern. Okay, and we're gonna try graphing this and try to remember the key concept of the 1, 3, 5 pattern when we're graphing the next parabola. Now we're gonna graph the following parabola here. We're gonna graph both. The original one, y is equal to x squared, and y is equal to 4x squared. We said the most important part, always start at the vertex. The vertex, whenever our parabola is in the form of y is equal to ax squared, the vertex is always 0, 0. So let's start at 0, 0. Okay? So always start at the vertex. In terms of the shortcut, so once we're starting from the vertex, so we start from the vertex and we're going to move now. We said that along the x-axis, the change or the difference in x is always 1. Now the difference in y, we follow 1, 3, 5, but we multiply 1, 3, 5 by whatever our a value is. So here, in this example, y is equal to x squared, our 1, 3, 5 pattern is being multiplied by our a value, which is 1. So in other words, from our vertex, the difference in x is 1. So we're going to move over 1 right here, Okay, actually let me use a different color. Right here, and then we're going to move along the y-axis another one. Okay, and that's where we're going to get our first point. Okay, we're going to move over 1 along x, and we're going to go, so we've done the 1, we're going to go another 1 to the right. Okay, so the x difference is always going to tell us to go right, and now we're going to go up. Okay, so this y difference always tells us to go up. The x difference always tells us to go right. So we're going to go to the right 1, but up. So right 1, 1, 2, 3. And then we're going to go to the right 1, and then the next pattern of the 5. 1, 2, 3, 4, 5. Okay, so here we have our parabola. Okay, and beyond that, it's not really going to matter. Of course, if you're in my class, I'm not going to really be picky. But I'm going to be very picky that you show at least the 1, 3, 5 pattern. Okay, it's 1, 3, 5 because which one are we graphing? Well, this one we're going to do in blue. We're graphing y is equal to x squared. Now, from the vertex, we said that there is this mirror. Okay, this mirror represents the axis of symmetry. Therefore, all we have to do to plot the next points are match the points. So we have this point right here that I'm reinforcing, and it would appear right here. We look at this point right here, okay, and we match it right here. Okay. Then we look at the next point right here, and we match it right there. And then all we have to do, of course, with a ruler, please, is extend the parabola. But now, we've already graphed this one. We've seen what y is equal to x squared. Now what we're going to do, and I'm going to do this in red. So red is going to be this one. Y is equal to 4x squared. What is the a value? Well, we said here, the difference always is going to be 1. The difference is always 1, which means we're always going to go to the right by 1 unit. Now, in terms of the y difference, this y difference is all determined by whatever the a value is. What is the a value? The a value here is 4. So, we're still going to use the 1, 3, 5 pattern, but the 1, 3, 5 pattern is going to be multiplied by 4. So, in other words, the pattern for this is going to be 4, 12, 20. So notice how 1, 3, 5, okay, we have 1, 3, 5 pattern for this, but now 4, 12, 20 pattern for y is equal to 4x squared. And remember, this 4, 12, 20, remember, what is the most important? Always start at the vertex. So we start at the vertex. The x difference tells us 1 to the right. So we're going to go 1 to the right, and then the y difference tells us to go up 4. 1, 2, 3, 4. And there's our point. From here now, we're going to go to the right 1, and we're going to move up 12. And I don't know if we're going to be able to have room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And of course, if we had it up there, that would be our 12. And so therefore, of course, you wouldn't be drawing these lines in. You'd just be connecting those points. And again, you don't need to do the same. You just have to follow it along here and match them up. And notice, just like we said, as the value of a became bigger than 1, the parabola got narrower. It got narrower, and look at where the first point for x was. Here's our first